and thank you to them for hosting. And this particular session is powered by the Global Gas Center, which is a not-for-profit organization dedicated to sharing information between gas industry experts and executives based in Geneva, and some of whose members we have on the panel this afternoon. On the panel this afternoon, I'm lucky that we have at least one member of the panel here in person. It's rather odd doing a conference where most people are dialing in, but we have René Bautz, who's chairman of the World Energy Council at the Global Gas Center, and also chief executive of GasNow, which is a Swiss gas company. Online, hopefully we should have Jean-Marc Leroy, who is external relations senior executive vice president for Engie.
Hello.
Anita. Oh, great. Welcome, Jean-Marc. Good to see you. That's one person connected, so we have 100% connection success rate so far.
Hello, Jean-Marc.
We also have, hopefully, Anita Orban, who is Vice President for International Affairs for Tellurian LNG. Fantastic. Good
Hello,
afternoon.
Anita.
We now have two afternoons. Anita is Vice President for International Affairs for Tellurian LNG. We also have Andrew Walker, who's Vice President for LNG Strategy and Communication for Cheniere. Hi, Andrew. Good to see you there.
Hello, Andrew.
Hey, good afternoon.
Last but not least, we have a joint team from GazProm Germania. We have Maximilian Kuhn, who's Government Relations Advisor from GazProm Germania, and also Sander van Roetelaar, who's communications manager for Turksteen. So I think we have a full house. Good afternoon, everybody, and it's really good to see you there. So the format this afternoon is the panelists will be giving short presentations in the order that I've introduced them, and then hopefully after that we'll have a discussion amongst the panelists. So, René, if you would like to start, please.
Okay. So I just will to move there. So can I have the first slide? Thank you. Okay, ladies and gentlemen, I would like to thank also Kostas and his team for inviting us at this conference on energy transition. And it's always nice to be here in autumn in Athens with this beautiful weather. Thank you very much. We will start with the first slide about the European Green Deal. As you can see on this slide, aims to prioritize energy efficiency and to develop a power sector based largely on renewables, but also a fully integrated energy system and digitalized energy system. I think we have some problem with the slides. The technical teams will come back. I just waited. Can you have the slide? It's coming. Such a surprise of the video conference. Sometimes we have to be flexible. But it will work, I'm sure. He's taking the USB key. Perhaps he has to relaunch the slides. I think it will come soon. Yeah, it's starting. It's a late afternoon, so sometimes. Just to start the slides again. Here it is, yeah. We are on the second slide. Yeah, here. Thank you. So we are back with the slides. But I wanted to say also from the European Commission that the future energy market has also to be secure and affordable, considering that already today some 50 million of households have problems to pay their energy bill. In the Global Gas Center, we are convinced that natural gas and its infrastructure will be part not of the problem, but of the solution, also with a net zero carbon target for 2050. The European Commission declared also the objective, you can see it on the next slide, if I can move it, yeah, which is in red, but it's quite hard to read, that gas has also to be completely decarbonized and to promote also smart integration across sectors. This will be surely the main challenge for our industry with the development of renewable gases, but also with CCS and U for the future. According to the International Energy Agency, coal to gas switching already had brought quite a lot of saving of CO2. It's about 500 million tons since 2010 worldwide. This is equivalent of a reduction with about 200 million of electric vehicles on the same period. But we have also to tackle the methane case. Regarding methane emissions, another greenhouse gas, emissions from the gas chain from production to distribution account for about 2.3% of total greenhouse emissions. Major efforts are currently being undertaken by the gas industry to reduce these methane emissions due to leaks, which are already low today compared to overall anthropogenic emissions. From 1990 to 2015, methane emissions from the European gas chain decreased by about 50%. I would like now to say some words about Switzerland. Natural gas currently accounts around 14% of Switzerland's final energy demand. It is the third most important energy source after oil and electricity. It is mainly used for heating and industry, especially industry also where flexible energy for high temperature processes is essential. But Switzerland is also a transit country, which you can see on the slide, with a main gas pipeline from north to south, connecting France and Germany to Italy. It transports 3 times more gas than the needs of Switzerland. And we just invested also for the reverse flow, and now we can also push physically gas from Italy to south of Germany or to France. So energy transition to a low carbon economy creates considerable challenges in terms of energy production, storage, and transport. Demand for renewable or decarbonized energy will increase in the future, and large-scale storage will be a key element in meeting the seasonality of supply and demand. Gas infrastructure can meet these challenges. Considering that a hydrogen backbone could be developed in Europe, we need to be prepared for this future also in Switzerland. There are 4 main factors that will limit the use of an all-electric system in Switzerland in replacing gas as an energy carrier. That's the intermittency of solar and wind energy, so peak power demand, especially with the seasonality of heating systems, but also storage needs and industrial processes with high temperature, which cannot just be replaced by an electric system. Several studies show that an all-electric model would be extremely costly and would diminish the security of supply based only on one single infrastructure. In Switzerland, the additional cost of such a model is estimated between 1.4 to 2 billion Swiss francs per year. A Swiss research institute developed a scenario showing the challenges of the power sector in Switzerland with the phasing out of the nuclear production by 2050. we can see on the next slide the situation in 2050. You can see in green, it's a power production without nuclear, mainly based on hydro in Switzerland. Then you have in yellow the solar production, based with a scenario that 50% of all roofs oriented south are equipped with solar panels. That's quite a lot. And you will see you have the dark line, which is the actual needs for power in Switzerland, and the other line above, which is a future need in 2050 of electricity in Switzerland, considering that we have 75% of heat pump installed, and the electric mobility will have a market share of 20%. So as you can see in orange, you will see we have an extreme production of electricity in summertime, but needs to import in wintertime. And there, the gas can also play a role in the situations that if we develop also gas turbines or CHP units, it's to help to produce electricity in wintertime, but also with power to gas systems to move the excess of energy in summer to the winter period. And I think we cannot avoid to have also quite large storages to use with the power to gas systems. That's a situation we will have in 2050 in Switzerland if we don't have any more nuclear power production, which accounts today about 40% of all electric production. So in the future, gas pipelines will transport not only fossil methane, but also biogas, synthetic methane, and from the excess of renewable energy and even hydrogen. Today, it is already possible to inject up to 2% of hydrogen into Swiss gas networks, but tests are going on to increase this percentage to 10 or even to 20%. The Swiss gas industry developed a new strategy for the next years. It is called the 30-30 strategy. It means that until 2030, renewable gases will be produced to cover 30% of the needs of the heating sector and gas mobility. To achieve these goals, more biogas must be produced, but also new power-to-gas units will be installed. Other projects are also key in the perspective of the Swiss Energy Transition Program, as the development of carbon capture and storage, rock caverns or LNG tanks to store low-carbon gases or hydrogen. GasNet has a long experience in the gas development. Next slide, it doesn't move. Yeah, here. GasNet has a long experience in the gas development. GasNet was created when switching from town gas to natural gas in the 70s. Now we have to realize the third revolution or evolution, as you can see on the slide, with renewable gases or hydrogen. It's a huge challenge. In short, natural gas is set to evolve towards a low-carbon worldwide energy carrier. And thanks to the investment already made in a well-developed infrastructure, new approaches will be possible with the convergence of the networks, also sector coupling. Thank you very much for your attention, and I will be happy also to discuss with you about all these aspects on the future of natural gas and renewable gases. Thank you.
Thank you. Thank you very much, René. That was a very useful introduction to some of the issues, I think, and also admirably on time. So without further delay, if we can pass to Jean-Marc, Jean-Marc, if you're able to get your slides ready and everything.
Okay, thanks, Alex. I will have no slides. And first of all, I would like to say how sorry I am not able to travel to Athens. But in my presentation, I will try to make you travel, because so the issue I would like to tackle today is the following: is Europe safe from the California power system failure we recently observed, and what could be the role of gas in this perspective? Because As you all know, electricity is a non-massively storable good. Therefore, the adequacy of supply and demand is a major concern of any manager of an electrical system. Furthermore, the energy transition that has started in many developed economies is shaking up both electricity supply and demand. On the supply side, the share of dispatchable fossil fuel production is rapidly declining in favor of intermittent renewable electricity production. On the demand side, the decrease caused by the so welcome energy efficiency measures does not compensate for the increase in the electrification of uses. I therefore asked the E-Cube and EV firms, the French and the German one, to analyze the evolution of this balance between supply and demand for electricity at the perimeter of northwestern Europe by 2030. It would have been very interesting to do that at the global Europe scale, but unfortunately, it would probably have been too costly for us, so we simply focus on this part of Europe. But I am quite sure that what we learn there can be easily transferred to other parts. We speak about 2030. This horizon of time might seem distant, but given the inertia of the electricity system, globally of the energy system, I would say, for instance, the time to upgrade the heating fleet or to build new production assets, the resilience of the system in 2030 depends largely on decision taking today. This study has just been made public on September the 7th. What does it show? It simply shows that in 2030, in a cold snap situation similar to those experienced by Europe in 1985, 1997, and 2012, a capacity deficit of 30 to 70 gigawatt could lead to blackouts for 100 to 250 hours. These cuts would mainly affect industrial customers, but also potentially individual customers, with an induced cost for the community estimated at 30 billion euros. Sure, even if the magnitude of the cost observed this summer in California, we are there talking about 1 gigawatt over a few hours, is not comparable with the risk identified in the E-Cube EV study, it seems appropriate to analyze whether the causes identified so far at the origin of Californian events exist or will exist in the near future in Europe. The lack of electrical capacity in California, described as potentially chronic, seems to have four main causes. Firstly, the non-availability of peak gas-fired power plants, either because they were withdrawn from the system or because simply the contractual mechanism for making the manager of existing peak capacity available have not worked. Globally, between 2010 and 2019, the capacity of dispatchable production units fell by 22%, while demand increased by 15%. Secondly, he lowers that expected availability of wind power capacity in a context of strong development in this sector. The wind farm having been multiplied by 2.5 since 2010. Then, a high but not exceptional electrical peak linked to massive use of air conditioning during a strong heat wave. And finally, the unavailability of import capacities from neighboring states experiencing a similar heat wave. What does this study tell us about the existence of each of these four risk factors for the European energy system? Dispatchability first. By 2030, 64 gigawatts of dispatchable capacity will be withdrawn in Western Europe, the equivalent of the entire French nuclear fleet. Intermittent renewable development, the EU's non-dispatchable renewable capacities increased from 13 to 325 gigawatts between 2000 and 2019. At this rate of deployment, we will have to increase to achieve the European Union, and this rate of deployment, we'll have to increase to achieve the European Union's carbon neutrality objectives. Speaking about peak management now, the sensitivity of electricity consumption to temperature could increase by 35% from 3 gigawatt per degree centigrade to more than 4 by 2030. The electrification of heating could lead to a significant increase in electrical peak in winter. Obviously, electricity interconnection capacities are developing in Europe, but unfortunately, there are some climate correlations from one country to another, and that exists both from the demand side. When a cold wave reaches Europe, it generally affects almost the entire territory. And it exists also from the renewable production side. When there is no wind or no sun in a place, it generally affects others as well. That makes that the potential solidarity contribution mechanism between countries might be rather weak in terms of securing the system. Even if, for Northwest Europe, the winter electrical peak replaces the summer peak related to air conditioning, it is clear that all California risk factors will be found in Europe and in much greater proportions. Fortunately, and that's the good news, there are solutions. And contrary to what you may have read in the American press, the event in California do not mean the failure of an energy transition based on the development of renewable energy. Simply, maintaining peak thermal capacities associated with a binding contractual mechanism on the provision of the 1.8 gigawatt of gas capacity, which was lacking in demand, would have made it possible to avoid any outage. Then, what lessons can we learn from all this for the European electricity system and also for the gas system? Firstly, it is essential to control the increase in the electrical peak by intelligent heating solutions, mixing gas and electricity. The only building insulation measures, essential as they are, will not contain the electrical peak associated with massive electrification of heating. Secondly, the maintenance of dispatchable production capacities, allowing a massive deployment of renewables, is the guarantee of the resilience of the electricity system. On paper, 3 types of technologies can be considered. Batteries, they are a very useful addition to photovoltaic solutions to flatten solar production, but it will not be sufficient to compensate for an event lasting several days without wind or solar, or to compensate for the seasonality of heating demand. To some extent, nuclear power can be dispatched, and some fleets offers a certain modulation capacity. However, the cost structure of nuclear power dominated by fixed costs makes this technology ill-suited to flexible backup operation. If the utilization rate is halved, the costs are almost double, which is why nuclear power plants only make economic sense to provide base load electricity. Gas-fired power stations, the cost of which are dominated by their variable part, are the best complement to renewable energies and batteries. Their contribution in terms of CO2 emissions will be reduced due to the low number of hours for which they will be used in the future, because they will be mainly used during the peak periods, and might be gradually turned to zero due to their capacity to burn renewable gases, be it biomethane or green hydrogen, as a substitute for fossil gas. Thus, the transition from the massive electricity mix to renewables and the reliability of the system can be compatible, subject to controlling the evolution of the electrical peak and ensuring the existence of reliable and economical peak production backups. and gas, and tomorrow green gases, have definitely a key role to play in this perspective. Thank you for your attention. I will be happy to answer some questions afterward. Thank you.
Okay. Thank you very, very much, Jean-Marc. That was a very useful explanation of how natural gas can back up renewables at a time when renewables are increasing on the system and also electricity demand is increasing. For our next speaker, if I manage to get my thing going, we have, I do apologize for this.
It's Anita.
Yes, sorry. We have Anita Orban, Vice President of International Affairs for Tellurian LNG. Sorry about that, Anita. Slight technical glitch.
Okay, please don't worry about it. So I just share my screen. And please let me know whether you see my presentation. Is it okay now, Alex? Hello? Hello?
Good here, I think.
Hi, Alex. Do you hear me?
Yes, we can hear you.
Excellent. And do you see my presentation?
If you put your screen on presentation mode, I think that's the only thing that still needs to be done.
And do you see it now?
Perfect.
Oh, excellent. Fantastic. Thank you. So first of all, I would like to thank for the organizers for the invitation and including Tellurian in the discussion. And I would like also to echo what the previous speaker said, that it's too bad that we can't be there in person. And I envy René and Alex who can be there in Athens in person. So good for you. I represent Tellurian, which is a US LNG company. And what else can I do then? Obviously argue for the role of LNG in the transition, for the role of natural gas in the transition when we are heading towards our 2030 or towards our 2050 target. And of course, the underlying theme or argument of my presentation that natural gas has to play a key role in the transition. And I will illustrate with recent data from this year how much LNG played in the European supply, and with its competitive prices, how much I believe it contributes to the recovery of Europe from the pandemia. And I would like to take also this opportunity to thank Global Gas Center for being on this panel and for all the work which it is doing for the gas industry and also for the LNG companies in the European, in Brussels, as well as in the various European capitals, making sure that natural gas is on the radar screen, and natural gas is considered as part of the future energy mix and the transition. So we have seen historic low gas prices and LNG prices in the last couple of months, but now prices started to increase, giving also a price signal for potential suppliers and also existing suppliers for further production. There are no major changes in the underlying fundamentals, which would explain that JKM and, more importantly for our discussion, also the European index, TTF, have increased in recent weeks. Some point to reduce supply from Gorgon, Cameroon, US, and Malaysia as potential reason for higher prices. But nonetheless, LNG trade remains below the 2019 levels in this year. When it comes to Europe, the TTF prices may have increased because we have seen a lower Russian as well as US flow into the market starting late spring, early summer. And this has removed the immediate danger of storage being overfilled, especially as Ukraine has stored the EU gas instead. However, at the moment, there is a lot of spare capacity when it comes to potential supply for Europe. And if we look only the major pipeline supplier, Russia, we calculate about a 55 BCM of spare export capacity to Europe based on the 2019 levels. This would all mean also the spare liquefaction capacity that we are not expecting any more price increase or significant price increase in the foreseeable future. That means that when we are talking about the green recovery 2050 and 2030, it is also important to keep in mind that when in July the EU budget as well as these targets were accepted, the EU also accepted the recovery plan of the 750 billion euros package. And in the recovery, while it's an underlying theme is a green recovery and a sustainable and climate conscious recovery, a very important factor is that Europe wants to keep its competitiveness. And the LNG, competitive LNG prices are contributing not only to the energy security of Europe, but also could be a significant factor when we go forward towards our target as the support behind renewable power generation, as well as a cheap and competitively priced energy source for European industry, as well as for households, whoever is relying on natural gas for heating or electricity generation. And this is an important factor which shouldn't be overlooked when we are looking for the years ahead of us. In terms of the forward curve, why we have seen super low TTF prices in the beginning of this year, which were like around $2 MMBTU, equaling around €6 per megawatt hour. You can see that we are expecting a gradual increase of TTF, which the price signal is already there in the market. It won't be a rapid increase. It is rather slow, but seems to be steady. Global LNG production, this is an interesting chart, illustrates how much it was below capacity. And I included this chart to show how one of the key features which LNG brings to the market, and when we are talking about recovery for 2030, 2050, then the flexibility of the LNG market is something which also the most flexible market of Europe, of the world, which is Europe, can absolutely work with. Pulling LNG when it's needed, relying on LNG when it's needed, relying on LNG when it's more competitive than pipeline, or when it supplements potential renewable power generation, and not taking LNG in when there is an oversupply in the market. So in 2019, the LNG production almost reached the overall capacity of the potential production out there. But as you can see, in 2020, it was way below the capacity levels, which means that we have even more flexibility potentially built into the system. The US exporters and the newest exporters were bearing most of the supply cuts. And now recently also Malaysia is cutting spot cargo exports reportedly because short-term marginal costs are higher than JKM prices. European imports from the US have been steady since January. They decreased, but they had both term, meaning long-term volumes as well as spot volumes included. European imports remained subdued during the whole year, and in South Europe, year-on-year, European gas import decreased 15%, and another substantial decrease happened in Turkey. It was almost 16% year-on-year. But most interestingly, when it comes to the EU sources of natural gas, then what decreased the most has been the deliveries, but as you will see, it is the pipeline imports which have decreased 21%, and LNG imports overall increased 8.5%, and also domestic production decreased 12%. So this shows that Europe has been absolutely relying on LNG, and interestingly, like Turkey, where the overall demand has decreased almost 16% year-on-year, LNG import grew over 40% in Q1 and Q2 compared to the previous year. And why is that? Because LNG has brought a competitive and flexible source for all the economies of Europe. And I would like to remind everybody, we are now in 2020 October, but there is not even a year ago when the new European Commission came into office. And the head of the Commission gave a so-called mandate letter to each commissioner, and among them to Kadri Simpson, the Energy Commissioner. And that mandate letter had a clear statement asking the new energy commissioner to rely on LNG when it comes to the transition of Europe toward a more sustainable and greener future. So what has been happening since then is remarkably, the market played the role, and Europe has indeed increased its LNG import compared to the pipeline import in relative terms due to the competitiveness and the flexible nature of LNG. EU pipeline imports decreased. Mostly the biggest decrease was from Russia, almost 30%, and then also very substantial from Algeria and about 5% from Norway. EU gas demand has decreased, but this is mostly due to the prices year on year by about 8%. And the EU storages are about 91% full, Ukraine about 85% full, but what we are seeing is that the filling up of the storage level has decreased substantially. So with all this reliance on LNG as well as pipeline gas of all the economies all over Europe, I believe that the role of natural gas could be in the transition as supplementing the renewable power generation, as well as a competitive source of energy, which can come now due to the LNG from various sources, which are diversified sources, which are secure sources. And it's really hard to see how it can be circumvented, what natural gas can bring to the energy mix of Europe. Thank you.
Of what's been happening in the last few months in these very unusual times in the markets, and particularly with a view of LNG imports and pipeline imports. So next, if we could go to Andrew Walker, who's Vice President of Strategy and Communication for Cheniere, another major LNG player.
Hi, Alex. Hopefully you can hear me okay. My Wi-Fi has been dropping in and out, but it was perfect during Anita's session. So hopefully that will be good. First of all, on behalf of the Global Gas Centre, we are delighted to be able to present to you today. I am one of the vice presidents. I'm sorry I can't be there in person. I would very much like to be in Athens today. That would be very, very nice. Joining you, Alex and René. I'm sorry I can't be there, but we're very pleased to be able to present to you today. Also on behalf of Cheniere, which is the company I work for, we're very pleased to be able to engage in this discussion and to make these 10 minutes of comments and then join in with the Q&A afterwards. If you're not familiar with Cheniere, and I hope you are, we are the leading US LNG exporter. We now have 7 trains operating with a capacity of 35 million tons per annum, which is about 50 BCMA. Just so that the organisers don't worry, I'm going to make 3 points in terms of my, through my 10 minutes.
Andrew, sorry to interrupt, but we can't see your slides. I don't know if you have slides.
I'm just going to say I'm going to make 3 points, Alex, and I'm going to make the first one verbally, and then I will go to the slides for the next 2, just so the organisers don't worry. And the three things so you'll have to look at me, I'm sorry, for a little while. The 3 things I want to talk about the key role that gas has in the energy transition globally, but in particular Europe, the important role it has to play, gas and LNG. I want to talk about LNG and the role of LNG in Europe to kind of put that into some context. And then I'll end by talking about some of the climate initiatives that Cheniere as a company is taking. So the first of those, the key role of gas in the energy transition. And I think there are 3 important points to bear in mind. And part of the reason I think gas has had a problem communicating its role is that actually it's a many-faceted role, which varies the gas markets globally are not homogeneous. They vary by region and geography. So gas has a multifaceted role to play, which varies by region and varies by timescale. The energy transition will take place at different speeds in different locations. Europe playing a leading role in kind of leading some of the developments. Other places, it's about energy growth and meeting energy growth requirements in the most environmentally friendly way. So 3 key points to bear in mind. Firstly, gas has a positive role where it can displace less clean burning fuels. Clean burning, either in terms of particulate emissions, air quality is a key concern in some parts of the world, but also carbon. And in particular, gas can have a very beneficial role very quickly by displacing coal from the energy mix, in particular in Asia and some of the emerging economies that are very coal heavy. But there are also still bits of Europe where coal still remains to be kind of reduced in the mix. Secondly, gas is going to play a necessary and functional role in the energy mix. Not everything can be electrified, and renewables cannot supply all of the required electricity. Gas will be a necessary part of the mix, and it will also be a functional part of the mix. Functional in that it will help stabilize the energy supply. It will help create the flexibility in the storage that will be needed for renewables to play an increasing role in the mix, in terms of seasonal demand matching, in terms of storage, and in terms of making sure that energy remains both affordable but also secure. Finally, the third point I think to bear in mind is that the existing gas platform really is a platform for future development as well of a low carbon role for gas in the future energy mix. And by that I mean the development of hydrogen, which is key for some, will be key for decarbonisation of some sectors, biogas, syngas, and of course continued use of natural gas, but carbon abated natural gas through CCUS, carbon use and storage. And then one final point I will add to those 3 is really, in order for gas to play those multifaceted roles, it's very important that it does not undermine its credentials through unnecessary methane emissions. Fugitive methane emissions in terms of accidental emissions, routine venting, flaring, and methane slip in engines. It behooves gas to reduce its own carbon footprint as much as it possibly can in order to show its credentials in the best light. So having made those points, I'll move to my presentation. Hopefully you can see the slides if I put it into slideshow. Hopefully you can see that. Hopefully you can still hear me. And I will kind of move through the safe harbour statements to the role of LNG in Europe. Anita talked very much about the current role of LNG, how it's helping Europe recover from the pandemic, how it's providing flexibility. I want to take a bigger picture look. If we look at the history of LNG in Europe, it started. Europe was where the first commercial imports took place, in fact, the first technical imports, but the first commercial imports were in 1964. So Europe really has had a 50-year kind of history with LNG. And LNG has played an important role as part of a multifaceted supply into Europe over that time. And you can see the diagram on the left shows pipes coming from the north, the northern corridor, pipes from Russia and the east, the eastern corridor, pipes increasingly up from the south and the southwest, North Africa into Europe. LNG historically has not only filled in the gaps, but it's provided gas to the places that are less well connected to the pipeline system. Increasingly, as Europe increases its connectivity, becomes a single market, it's more about filling in the gaps and competing, diversifying supply along with pipeline. Although there are still some places, Iberia, southeastern Europe, that are less well connected, where LNG plays an important role. So what do we expect for the future, looking out in time in terms of LNG requirements? Well, Europe is a mature gas market. So if we look at the bar charts in the middle, this is the Woodmac view, but it's very similar to other views. You can see in terms of gas demand, gas supply into the wider Europe region. So this shows the EU 28 at the moment, 27, plus 11 other countries to kind of fill out the geography. So extending kind of into a geographic region. You can see they expect gas demand in Europe to stay pretty steady, declining slightly over time, from around about 550 BCM last year, dropping down to 500 BCM by 2040. But you can see within that steady gas demand case that actually indigenous production is declining. Europe will need an increasing amount of imports. You can see the other piped, which is basically Norway, North Africa, Azerbaijan, is expected to stay fairly steady over that time. So actually it falls to both LNG and Russian pipeline supplies to meet the growth in imports over that time. And I think an important point is that Europe both needs and probably desires a mix of supplies, a mix of LNG pipeline supplies, pretty much all of the above. There is an uncertainty in that outlook, though. You can see that Wood Mackenzie, that's their base case. They have also created an advanced energy transition 2 case, in which the energy transition happens more quickly, that gas demand drops more rapidly than expected. But you can see their view is that in a 2 degree, a case consistent with 2 degrees, that actually that drops in the foreseeable future only by 100 BCMA. Now, the targets which the European Union has recently set itself to reduce emissions by 55% by 2030 would probably bring that reduction forward to 2030. And clearly there's a target which is energy neutral by 2050, in which unabated gas use in Europe is much reduced by 2050. So there is an uncertainty to the shape of the curve as to how quickly gas demand reduces and how quickly it kind of comes down to meet the carbon neutral targets over time. But as Klaus-Dieter Borchardt said yesterday at a conference, this transition is a multi-decade work in progress. 10, 15, maybe longer years was his view in terms of fossil fuels playing a large role in that market and then starting to evolve into a lower carbon or being replaced by other renewables. So there is a question about the shape of the curve, but I think, in my view, there is a meaningful role for gas to play in the energy mix and a need for LNG and pipeline both in the energy mix for the foreseeable future. So moving on to say a few words about Cheniere's climate and sustainability principles. We were pleased to publish our first ESG report earlier this year in July. We're a fairly young company in terms of exports. We started in 2016, but we have started to think about how we engage and meet societal requirements for a lower carbon footprint. And we've thought quite hard, and we've put in place 4 key principles which underlie our thinking. From north to south, we are very much thinking about how we can promote and improve the science of methane measurement and reduction. We are believers that actually there's the data in terms of carbon footprint, methane emissions is very variable in terms of quality. There's a range of views. Those views do tend to get cherry picked by those who are pro gas or against gas, those who are pro fuel versus other fuel, those who are pro region versus other region. I think it's in everyone's advantage to have good data in terms of on which to base their future decisions, and we're very supportive of science of methane measurement and reduction. We're also very keen on increasing transparency with stakeholders. For us, that's not only our shareholders, but those who are going to make decisions in terms of future fuel requirements based on carbon measurements, amongst other things. Very keen that everyone is able to put forward transparent and verifiable data that can be used in those decisions. Across the east-west axis, horizontally, what can we do to help ultimately reduce the carbon footprint of LNG? Well, there are two things we can do. We can focus on the area that we have control, and that for us is LNG liquefaction and shipping. We can look at how we increase efficiency of our system, but also how we monitor and reduce the greenhouse gas emissions. And actually, in the last 3 years, we've managed to reduce our Scope 1 emissions in terms of intensity. Bear in mind, we're a growing company, but in terms of greenhouse gas intensity, we have reduced them by 1/3 as we put in place technical measurement and reduction mechanisms. And then we are the largest consumer and buyer of gas in the US. So obviously we have a lot of influence that can extend into the upstream, and we can work with our suppliers, our gas suppliers, our partners to understand what they're doing in terms of reducing their environmental impacts in their bit of the chain, encouraging them to do that and working with them to ensure that they are kind of moving forward to reduce the greenhouse gas emissions in terms of the upstream, the finding and the production of the gas. So I think that's probably my 10 minutes. So I'm going to hopefully become visible again on screen and pass back to you, Alex, to say it's been good to present to you, and I look forward to the Q&A later in the discussion.
A great overview of how gas is still going to have a large role to play in the next few decades, and also as part of the transition. And just my apologies for the interruption over the slides earlier. It's all a bit challenging, this kind of remote panel chairing, but thank you very much for that. That was very interesting. So we're now on to our last speakers, last but not least, Maximilian Kuhn of GazProm Germania and Sander Rutzler of Turksteen. So Maximilian, if you're ready and if you'd like to start, that would be great.
Hi, thank you very much. I will jump right into my presentation, not to lose any time, but it's a real pity that I cannot be with you in person. Let me just I hope you can all see the presentation so far. So I'm here to represent GazProm, one of the largest gas companies, and it has a very long history of gas production and therefore also a lot of experience in that field. And we can see that GazProm is a low carbon footprint leader in providing natural gas when compared to 26 larger oil and gas companies worldwide. So this was the outcome of a CDP report. Overall, Russia is also committed to the climate policy and to the Paris Agreement, and is implementing the national roadmap for climate change adaptation. And this also has impact on the GazProm future studies and also on our work. I want to highlight the three-step approach, which is switching from natural gas or switching to natural gas from less ecological friendly fuels. Is the first step. We can reduce, for instance, the emissions in Europe already roughly by 18%. By introducing a methane hydrogen mixture, we can also reduce another 35% of the emissions. And by then introducing clean hydrogen, also from natural gas, we can reduce another 80%. I will come to this point later with a case study on Greece. Just a small remarks on the methane emissions, because it was said before and it is a very important topic. GazProm has already a very low methane leakage ratio. It's 0.02% of the overall production of gas. When we look at decarbonization, let us also take into account all aspects important for the energy transition. This study, but also various other studies, have shown that fast emission reductions is only possible with natural gas, and further emission reduction only with hydrogen. And there all types of hydrogen play a role. But I also want to highlight that the land use aspect is also very crucial, because you can see that natural gas has among the smallest land use impact when compared to other forms of energy supply. Another important aspect is the integration, the smart system integration. So natural gas gives excess electricity the possibility to be integrated or stored in form of gas, in form of methane, and to use existing infrastructure. So we have produced a new study on the life cycle emissions of natural gas transport via Turksteen to Central Eastern Europe. And you can already see that on the breakdown of the main processes here, the colored map, that the natural gas supply via Turksteen to Central Eastern Europe has one of the lowest footprints, overall footprints on the region. And on the right side, it might be on the left side of yours, you can also see the methane emissions. And here also the gas supply via Turksteen is among the lowest. But let us also look at some more dedicated facts. So this study also looks at various countries, among others also Greece. So here it looks at the electricity generation and at the heat generation in Greece. You can see from the different colors different impact categories, because it's not only CO2 emissions and the global warming potential which is important, but also other fields of emissions like ionization, acidification, eutrophication, non-cancer human health effects, water scarcity. So all these impacts have an impact on society, on the environment, and on the whole human life in the end. We can see in the graphs that natural gas via Turksteen has among the lowest footprints. And then if we, for instance, look at this picture, we can see that there's also other impact categories where renewable electricities or renewables have way higher impact on the human health than natural gas has. For instance, with ionization. When we look at toxicity of fresh water, of water scarcity, certainly a topic relevant for Greece as a region. Also here we can see that natural gas performs better than other fuels, especially also oil, biogas, but also biomass and PV. Also here, when we look at cancer human health effects, we can see that natural gas or natural gas via Turksteen, which is even less impactful, has a very good standing and performance for the electricity and the heat supply increase and in the overall heat region. I think this is a very important point to consider for policymakers when looking at all the available technologies or energy sources. You should always look at all impact categories so that you can take the fuels or the sources which have the less impact. We also looked at how each country can achieve their national energy climate plans for 2030, and following the logic of the three-step approach, we can reduce the overall emissions by 1% if we replace all natural gas by Turksteen gas, and then we can replace more polluting fuels by natural gas, and we can further reduce it by 27%. Then by replacing with a methane hydrogen mix, or ultimately after 2030 with a hydrogen directly, we can reduce by another 42% the overall emissions just in the energy sector. So I think there's a huge emissions reduction potential provided by natural gas to the region and to Greece particularly. GazProm's vision for 2050 is following the decarbonization of energy carriers. So we see coal with a lot carbon molecules, then crude oil, then natural gas, which is already the best fossil fuel with only one carbon molecule and 4 hydrogen molecules. And then ultimately we move to hydrogen. In our vision, we move to hydrogen by splitting natural gas, CH4, into 2 hydrogen molecules and solid carbon. This energy process has 87% less energy needs per hydrogen than electrolysis, and 40% less energy need than steam reforming. So methane pyrolysis is also the only technology that can provide integrate all types of methane, from biogas, from waste, from natural gas, from sewage, and it can be turned into clean hydrogen, heat, and solid carbon. And when it comes to the carbon footprint, we can see on the upper right, we can see that already today electrolyzes hydrogen. We see in orange here with a 2020 and 2050 energy electricity grid mix performs way out of the taxonomy or the certify range, which should be eligible for clean hydrogen. But we can see that the blue and the light blue and the dark blue ranges, which show pyrolysis technologies, various technologies from pyrolysis, which perform much cleaner than other technologies. What we can also see here is that the production cost for clean hydrogen from natural gas is already way lower than that of green hydrogen, which needs another 80% reduction until 2050. And here, turquoise hydrogen can already perform very well. With this, I can end my presentation, and I'm ready to answer your questions in the discussions. Thank you.
Great. Thank you very much, Maximilian. So I presume that's the joint presentation for you and Sander, is it?
Yes.
Super. That's great. Well, we have about half an hour, 35 minutes of discussion. I think what we've heard is a very useful summary, not only of the role that natural gas can play in terms of continuing to help decarbonization, the benefits of competition between the different sources of imports for natural gas, the significant continuing role for natural gas up to 2040. As Andrew said, some uncertainty about the shape of the curve, but still a substantial market. And we've also heard about some of the challenges about relying on the all-electric pathway. Now, this next bit is going to be a little bit tricky because fortunately I can see everybody. but I don't have any other means of communicating with you. So what I'd like to do is start off by asking some questions, but if you want to jump in and get the discussion flowing rather than a very stilted method of me just asking the questions, please just raise your hand and then I will see you and then we can go from there. So hopefully we'll get a flowing discussion. Time will tell. I'd like to start with René, if I may. You mentioned about the issues for Switzerland and with the increasing electrification and the potential issues that would raise. And you also mentioned the role for natural gas in that. Could you sort of explain a bit more about that? And do you think that policymakers, for example, realize the challenges of the all-electric type pathway or the challenges that increased electrification raises, and therefore the role that natural gas can play in helping answer those questions?
Yeah, thank you for the question. That's really a thing we have to look at it much more closer in Switzerland, also with the politicians, because we have a problem today that there's such a big discussion just with electrification, especially in the mobility sector, but also in the heating sector. But everybody is thinking that just have to install heat pumps and I resolved the carbon footprint problem. But when you look at the reality, and we are happy also to be supported by some really academic and research institute, that we have a huge problem to solve. If we go in the field of a whole electrification, we will still have some problems, especially in wintertime, because we will have so much production in summer with all the solar panels, also with hydro. But in Switzerland, hydro is almost, I would say, exploited. We don't have too much to build with new hydro. It's not enough room to build new dams, especially pump storage dams. So I think only with solar panels, we cannot solve the problem in Switzerland. And the key element is on one side, the storage, but also how we can also produce more electricity in wintertime, especially if we have some more heat pumps. And then we think that, for example, also in the heating sector, CHP units will help, driven by natural gas, because we can increase efficiency from, let's say, about 50% to approximately 75%. That's sure one solution, but it's quite a problem now to push the solution with our politicians, because they only look actually in the electrification side. But another solution is also to use more natural gas and biogas in the mobility, because we made some studies. For example, in the mobility, if you take about 20 to 30% biogas in the mix to drive GNV vehicles, so if you take the life cycle analysis, we are as good as fully battery-driven vehicles. And we try also to push the message that we should also see other things, not only the electron, but also the molecule, and to see how we can green the molecule. And perhaps we have also in Switzerland to push more with lighthouse projects. For example, when I invite the media, for example, our general meeting at GasNet to talk about natural gas, just few medias will come. But just a few days ago, we inaugurated our first power-to-gas project, really a lighthouse project with a new methanation reactor. So all press were present. So I could not only talk about the lighthouse project, but also play some messages about natural gas. So I think also what just Andrew said, it's always, and it's more important in the future, that we have a better communication in the gas industry. And we have to push also our projects in the future and to show that natural gas and renewable gases are a key element also for the energy transition.
Mm-hmm. Okay, thank you very much. If I may, if nobody has an immediate comment, I'd like to follow up with Jean-Marc on that, because Jean-Marc, you also mentioned about the issues to do with electrification, and you made the point that natural gas can be a very good complement to renewables, and with the low operating hours, it would have very, very low emissions. But picking up on the point that René just made about communication, one of the problems I think we have as a gas industry is that some people still see that as emissions. So you're burning natural gas, you might be burning less, but you're still burning natural gas and that has emissions. Is there a way that we can explain how natural gas still has that positive role to play in the way that you mentioned, and overcome that that reaction?
Thank you, Alex, for this question. I think today in Europe, you might find some people looking at the world with two colors only. I would say green and black. But can you perform a symphony only with two notes? Okay, so we have to consider the result. The result is clear. In Europe, we are moving forward in 2050 a carbon neutral economy. That's very clear. But the trajectory and the transition should also be taken into account, because we are also in a kind of emergency as far as climate is concerned. So any solutions which is able to lower the emission is good to take today, especially if at the end of the story you have the final solution of having this solution being totally green. And the panelists mentioned a lot of ways to achieve that. So I really think that we have to be more, I would say, clear on the advantage of gas and the ability to decrease very quickly emissions thanks to replacing fuel by gas or coal by gas. And that will not be the end of the story, because afterward, gas will be greener and greener again. So let's explain that there is more than 50 shades of green.
I'd like to follow up on that to all of you, if I may. So be prepared to put your hand up, please. One of the issues that I notice in a lot of the debate is that people are very good about talking where we will be in 2050, but they're less good about talking how we will get there, given the enormous changes that are required for our energy systems. And clearly, as a number of you have said, natural gas has a huge role to play there, not just in the traditional switching from coal to gas in power generation, but also in other segments of the economy. How do you think that we can get that message across better, that, you know, it's great to have a dream of net zero in 2050, but you have to get there? And also the issue is, the quicker you reduce emissions now, which you can do with natural gas, the more time and carbon budget you have in order to develop the new technologies, which at the moment are considerably more expensive. So I wonder if anybody would like to volunteer to answer that question.
I'll help you out, Alex.
Thank you, Andrew.
In terms of communication, I think, you know, it's been a learning process for the industry. You know, we do perhaps agonize that we haven't got our messages across very well, but I think part of that is that this is a very fluid and evolving challenge at the moment, the energy transition, as you yourself said. How the destination is clear, how we actually get there is much less clear, and how long it takes, and the route that we go. And then the gas industry has, by its very nature, kind of become a very diffuse thing as well. You know, there are utility companies, there are gas companies, there are gas infrastructure operators. They all have a very different perspective on this. So it's perhaps not surprising that it's very hard to get a single voice representing the industry. But this is where I think associations like the Global Gas Centre can help, because they can bring those various perspectives together, different geographies. We are a global gas center, as the word says. So we have representatives from Europe, but also from Asia, from around the world. And as I said in my comments, this is not only a multifaceted solution, and we don't know what that solution looks like across various things: renewables, hydrogen, biogas, syngas, everything. We also don't know what it's very hard to define the problem, because the problem is different in different places. If you go to Asia, they focus on very different things, air quality, compared to some of the developed world, where it's more about carbon footprint and the environment. So actually, it's a multifaceted problem with multifaceted solutions. And this is where I think the Global Gas Center can help bring together the messaging into something that's coherent across those, start to underline fundamentally where gas works. And again, I think there's a different role in messaging to politicians who perhaps understand the challenges and the complexities versus messaging to the general public, where it's very much a much more ideological battleground, shall we say. And it's one that we will never win with some people who have a dogmatic ideology. It's really the middle ground where we have to demonstrate the pragmatic benefits of gas in terms of achievability, in terms of sustainability, and in terms of affordability.
Alex, if I may add to what Andrew said, when we have such a big problem or vision ahead of us, like the transition to 2050, it's always good to break it into steps. And I would reframe the debate. And why don't we also start talking first about how we reach the even more ambitious goals for 2030? Because as soon as we start talking about that goal, then we can see clearer the role of natural gas, which it has to play between now and 2030. And I really liked both Andrew and GazProm Germania highlighting that the industry is conscious and the industry is working on its own emission numbers. It's the true also for Tellurian. And also what Andrew said, that natural gas and LNG or forms of gas can come into various new ways of using, which have been relying on a much more polluting or environmentally less friendly fuels. So I would recommend, when it comes to the question of communication, that we should concentrate on the 2030 target first, and how do we reach that, and how natural gas can help the EU really reach the rather ambitious but well respected target for 2030. And then we can see what was the cost, what are the benefits, and then we can work towards the 2050 goal as a next step.
Okay, thank you very much, Anita. Does anybody else have anything to add on that before I ask my Jean-Marc?
No, if I may, I would like also to highlight that, especially speaking about Europe, we have made a lot of progress so far, because clearly I made few people, to be clear, fully convinced that all electricity will be definitely the solution. Or a lot of people are really considering now that an holistic vision will be better, and not only for achieving the energy transition, but for making, as it was said by Andrew, it affordable and also secure. Because there will be no energy transition if it's not affordable for the citizen. And I don't think that citizens are keen to pay more for having less services, less security of supply. So that's the good face of the coin, I would say. I do also consider that as industry, we also have to meet certain challenges in order to make our story credible and hearable. The first one is probably methane leakage. It was mentioned also by some panelists, but it's really a key issue. We have to demonstrate that we are able to manage the gas industry in a very safe way as far as methane emission is concerned. That's the first one. We had also to make the green gas these gases. I will speak about biogas, synthetic gas, biomethane, or green hydrogen, or blue hydrogen as well, which is also something probably to consider. We have to make that credible. And we have to demonstrate on the field that we are able to deliver on this kind of solution in a reasonable way, I would say, also as far as affordability and availability is concerned. So we have also a part to do in the conviction effort. It's not only a communication effort, it's also a mobilization of the industry, working hard in order to demonstrate that we are going in the right direction.
Thank you. Oh, Sander, yes, please.
Yeah, I'd like to add an additional perspective to this, and I totally agree with Jean-Marc saying that the EU has already come a long way, and obviously there's still a long way to go. My perspective is, well, as a Turksteen project, we obviously land in Turkey, and there's a completely different development going on over there. So all these European countries try to reduce carbon emissions compared to 1990 standards. And in Turkey, since 1990, carbon emissions have almost doubled. And there's a massive growth of coal-fired power generation. If you take Turkey into the equation in Europe and look at all the planned new capacity for coal-fired power generation, then it's 72%. So that's quite massive. So in our role in advocating natural gas as well a part of our transition, yeah, there's also plenty of reason to look at our neighbors and try to generate an understanding that that our best efforts will be required in these nations as well, even though they have their own challenges. It's not something that we can ignore. If you sit here in Greece, for example, that just 100 kilometers away from you, new power plants are being built.
Thank you for that, Sander. I'd like to pick up on that, focusing on the region, and then afterwards, I'd also like to go to Maximilian about the pathway that you illustrated, you know, reducing emissions over time. So the question is, Anita, it's on the role of LNG in southeastern Europe and the regional market. You may not have heard, but earlier speakers in the sessions this afternoon highlighted the role of LNG in terms of shipping, in terms of helping island economies, in terms of heavy transport, also in terms of displacing coal. And the representative of the US Department of Energy made a comparison between the Caribbean, where you have lots of small drop LNG, and this part of the world, Greece and the islands and the region at the East Med. I just wondered if you had any sort of thoughts as to how LNG could play a role there.
Andrew?
Okay. I think it obviously does have a role to play, Alex. As an industry, it continues to globalize, continues to become increasingly flexible, increasingly liquid, and it is kind of moving out into other sectors. So you're seeing the growth of bunkering in terms of infrastructure being put in place and in terms of commitments to ships. You're seeing small scale finally emerge. So you're seeing the true globalization and diversification of the industry. Some of this has taken a while, but I truly believe we're at that point. So for places like the Caribbean, for islands in the Med and in Asia, I think we're seeing small scale LNG, break bulk, we're seeing bunkering, of the above happening at a rate of knots that mean you know, those will be meaningful sectors as we go through the next decade, 2 decades, 3 decades. And it's been some time coming. We note that some of the infrastructure has taken quite a long time. Croatia is due to get the Kruk LNG terminal in place in early next year. One of the first people I met when I joined the industry, and that wasn't a short time ago, was the project developer of Kruk LNG. So some of these things have taken time, but I finally think that LNG has matured and has kind of come to a point where it's playing a very diversified, almost commoditized role. And that means different things for different people, but it's ultimately good for shipping, it's good for island nations, it's good for Southeast Europe. Important role, I think, increasingly important role, and Anita highlighted it. We've seen imports increase in Turkey this year. I checked Greece because you're in Athens, and I was pleased to see that actually 2.5 million tons just below imported last year. Greece has already done 2 million tons to date, so LNG imports up into Greece, important into Athens and that region. And I'm extremely pleased to know that 50% of that was US LNG. So LNG growing and diversifying, and US LNG having a beneficial role in that.
So if I may add, in this region we have experienced LNG buyers like Turkey and Greece, as Andrew mentioned, but we are also newcomers into the industry. So LNG is also, in the traditional gas source sense, is opening up for a brand new way of customers. And Andrew mentioned Kruk LNG, which will be up and running, and Hungary, which is a landlocked country, just announced a 6-year deal with Shell, LNG delivered to Kruk. And I think this must be one of the, if not the very first deal when a landlocked country-based customer is announcing or having a midterm deal delivered to a different country's port and in the history of LNG industry. And also Bulgaria, which is another, in this sense, landlocked country. Of course, it has the Black Sea, but the Black Sea doesn't have LNG terminal. It has been buying spot LNG cargoes via Revitusa, via Greece. So LNG is now becoming part of the energy mix of Southeastern and Central Eastern European countries. And in Turkey, as well as in Greece, it had an impact in the last 9 months when it was outcrowding pipeline gas. And in Turkey, pretty much all the term contracts went to the obligatory volume, and the rest was supplied by LNG spot shipments, among them from the US. And the reason it could be done because of the competitive and flexible nature and accessibility of LNG. And the Greek islands and break and bulk could be a potentially new source of growth potential for the LNG industry, where LNG could play a role also in shipping as well as power generation in much smaller quantities in smaller demand locations. That is something which the industry is looking at as a new growth market and potential. Of course, here the role of aggregators will be bigger, as well as new technologies, but certainly East Mediterranean as well as up in the north, I could see break and bulk opportunities from Kruk or from Rovigo or other potential LNG regas terminal locations or regas terminals.
Okay, thank you. So sorry,
if I could give you one more comment. I think, I was counting up the European regas terminals this morning. There's 30 pretty much all around the coast of Europe. I think it's hard now to find a European country that hasn't imported LNG either directly or, as Anita's saying, indirectly. Even Hungary now has a contract. Congratulations, Anita, as a landlocked country. So it's filling in the gaps, it's creating competition, it's creating increasing market efficiency in that marketplace, which was always the European kind of requirement of LNG, or the aspiration for LNG. Sorry, Alex, back to you.
No problem at all. Thank you. Xander, I saw your hand up, but I have a question for Maximilian. Would you mind if I ask Maximilian, and then you can add on to that? So Maximilian, my question is, or at least the background to my question is, GazProm is the largest supplier of gas to Europe. It has, in many ways, been one of the foundation stones of the European gas industry, with the pipelines that have supplied gas and newer projects such as Turksteen. So it obviously has a role to play in the type of backup activities, the complementarity to renewables that was mentioned earlier. But you also mentioned in your presentation a pathway how we can meet the decarbonization targets, first through using natural gas, then through using a blend of natural gas and hydrogen, then ultimately sort of moving more to low carbon gases such as hydrogen. Because part of our task as a gas industry seems to be helping people understand how we're relevant, not just today, but in the longer term, I wonder if you could expand a bit more on that pathway.
Yes, certainly. It's totally correct, as you highlighted, is that we have a long history in supplying gas, and we also see a long future in supplying gas as fuel. And in our vision, and this was mentioned by Jean-Marc, I think, or Andrew as well, is the aim is to reduce the carbon budget, or to use the carbon budget. So implement, there's a small echo, I will try to use the microphone, maybe it's better for you.
Yes.
I hope you can still hear me.
What I wanted to say is that the fastest way to decarbonize is with natural gas, and this has been said before. But we also see a pathway with natural gas still plays a role in 2050.
I'm sorry, Maximilian, your microphone, it seems to have got worse. We're having a bit of trouble hearing you. I do apologize. And I think, yes, okay.
No. So we see a pathway for gas, and Russian gas in particular, also until 2050, where we, in our vision, we of course, we see all types of decarbonization options, but we also see a good competitiveness of methane pyrolysis. So that's what we look at in particular, where we split the natural gas, CH4, into its compounds, so hydrogen and solid carbon. And for instance, yes, it will produce a lot of solid carbons as well, but the solid carbon is easy to handle, it's easy to store, and it brings a lot of emission reduction potential for other sectors. Let's, for instance, start with the cement industry or the building industry, isolation, electricity cable, asphalt. So you can go through a range of industries where it can reduce their emissions. So other sectors which are hard to decarbonize can be helped with these two products, hydrogen and solid carbon. We also see a big potential to integrate waste, biogas and other gases, and to ultimately form negative emissions, which then can offset all low methane leakage rates or other sources of leakages. And we know from the European Commission that negative emissions are needed to achieve the overall climate targets. So there's a big way to integrate sectors which have been not thought of. For instance, plastic waste, which is a big issue globally, can be then integrated into the gas industry. We also see some potential for soil enhancement of the carbon, because the soil stores more CO2 than the atmosphere, way more CO2 than the atmosphere. And the soil can also take, with the soil enhancement of the solid carbon, like it's called terra preta, it can increase the growth of the plants, but you also can increase the nutrients and the water retentivity of the plants. So it helps dry regions, and we have a lot of dry regions already in Europe, to store more water. And if the plants can grow bigger, they can store more CO2, so this also creates negative emissions overall. So we see a lot of potential for natural gas applications in the future, but also for the two products.
Okay, thank you very much. Sander, sorry for cutting you off before, but if I may, if I can give the last word to you before asking if anybody has any other final comments, and then we'll wrap up.
Okay. Yeah. So I was listening to the comments about LNG, and actually I have a bit of mixed feelings about it. The reason is, well, it's good to diversify, so I totally acknowledge that. It's good for the end consumers, and it, as we now see in the gas market, it reduces prices as well when there's an abundance of gas available. On the other hand, what Maximilian showed is that the carbon emissions over its life cycle of American LNG is more than double of the carbon emissions that you'll see of pipeline gas. So this is something that has to be taken into account as well when having ambitions of reducing carbon emissions.
Okay, thank you. Any last comments or points that people would like to make before I attempt to summarize what's been a very interesting discussion? I thought there might be. And Andrew, and then Anita. Oh, and sorry, René as well.
But afterwards, just give Andrew some word first.
So, Andrew, please go first.
Yeah, I'll respond to that. I think you know, the European Commission, if we take Europe as the key market arbiter for this, has been quite clear that they are going to look at the measurement and verification of methane, and so we all have to come to the table with verified measurements. So it's great, we can compare each other now, but actually at the end of the day, the science will see whether your indications, your assertions are correct or not. As I said earlier, and I said it very specifically, there's a wide range of data, and there's been a lot of cherry picking in order for people to make their points, and that's exactly the type of thing I was referring to. So I have no doubt that when we come to look at the science and the measurement of this, and that was why Cheniere has been very specific about its climate principles, we are very much about transparent, well-measured and verified data, and the EU has been very clear that self-verification is not going to be acceptable. It will have to be done by an independent third party, probably specifically one with a knowledge of the science, and probably not one that we've paid to make the measurements as an industry. So I have no doubt that actually that discussion will mature over the coming months, years, and that actually science will create verifiable, transparent data on which people can make decisions. And we're very happy to have that comparison made, because we think as we look at our emissions, we are competitive. Now, for me, the big question is about gas versus coal in Asia, and clearly that's a first level of measurement and demonstrating that gas does have a very verifiable and measurable advantage over coal. But similarly in Europe, as you say, there's going to be a European carbon tax. So I have no doubt that we will be making, as long as the measurements are verifiable, as long as the framework is fair, we're entirely comfortable with that and believe we will be able to compete.
Okay. Anita, if I could ask you very quickly, and then René, and then I'll try and wrap up, because although we started late, I think we are now using our time, but I think we have had a very useful discussion. So Anita.
Thank you. 2 comments. Sander, I am really happy that you, and I'd like to commend you also for seeing the competitiveness of LNG. and that you just said that you can see how it is good for the consumers and why it brought diversity, security, as well as affordability, as well as pushed prices in Europe down. On the other hand, when it comes to the statement on the emission rate, this is not the first time I hear this allegation, and I would be really cautious making such a statement that US LNG or LNG generally double emission than GazProm. As Andrew said, we don't have the data, we don't have the science, we don't have any verified method of measuring emissions. We also, as a company, Tellurian, are aware of our emission numbers and are absolutely looking forward to a unified and verified system and method, and comparing and contrasting, and we are also very bullish on our competitiveness also on environmental terms. But I would be really cautious making such a statement about competition when we don't have any underlying data showing the way.
Okay.
Just very quickly, Alex, I must jump in there. I fully agree with Andrew and Anita, and we fully support your approach. But in the end, it's physics, not science. So there's just more energy in the process with regasification and gasification than is with pipeline transport. So in the end, it's all about physics, and all these physics shall be verified and checked. And we will have continue this discussion in the future. Thanks.
We look forward to
last. I'm going to assert my chairman's authority here, if I may, because we are running very close to time. René, if I may give the last word to
really
you.
short, I wanted to say, we have really to pick the low-hanging fruits with natural gas, because so we can save time, but not only time, but also money to invest in new technologies. And when I look to the energy patterns we have, for example, in the International Energy Agency or the BP outlook, we see that oil and coal will be reduced in the future to up to 2040. But the share, it's clear, for renewables will increase quite a lot, but also gas. Gas will increase from 24% to up to 27%. In part of the energy demand. So that means that clearly gas is a part of the solution and is not a problem for the future. And we have to work on that also at the global gas platform. And I think we have to develop a holistic approach. And there's good reason to develop also the Global Gas Center to have these discussions and to promote this message.
Thank you, René. I think that's a very good note to end on in terms of the Global Gas Center and promoting discussions. Thank you very much to the panelists for what was a very, very good discussion. I always worry at the beginning of these things that there won't be enough questions or discussion. And then, of course, the trouble is trying to stop the discussion on time. So thank you very much for keeping it going. I think the couple of comments I would like to make to summarize, clearly gas has got a very important role to play in the future. Not just in the short and medium term, but also in the longer term. We have a task still to communicate that to other sectors of society, which I think we all agree on. I think we all have recognized the importance of the methane emissions issue, which is something that as an industry we get accused of ignoring, and quite clearly we're not ignoring it. And also it's good to see that there's such a lot of competition between the various players in the chain, because that's what spurs innovation and a better deal for the consumer. So on that happy note, I would like to thank you all again, and well, hopefully see you in person at some time soon. Thank you very much indeed.
Thank you, Alex. Thank you, everybody.
Thank you.
Bye.
Okay.